Hello everyone. Today I'm going to give a demo of erythrocyte classification using machine learning language. In this project, we will detect the type of diseases which is present in the erythrocyte. So initially we have collected the data set of erythrocyte, and after that we are going to the train the model. Last step is classification. So now we go for the code. Here type ideally. Click on open. Click on file. Open. Click on training file. So now we go for the dataset folder. So you can see here type of diseases which is present in the erythrocyte. Click on this. So here you can see the images of cholestasis, elliptocytes. So these are the diseases which is present in the erythrocyte. So the main aim of this project is to detect type of diseases when we upload the images of particular file. So this is the training code where NumPy is used for to convert array conversion and TensorFlow is used for to train the model. Log is used for list all the files. Here we are used type of disease 9 and this is the folder name dataset. Once we loaded the dataset, we convert in each image into array format. And after that, we are splitting the dataset into train and test. So here we are printing the total categories, total images, and training images and also testing images. So this part is used for to convert the image into RGB, then 3-dimensional, and last 4-dimensional. Once it is converted, it will display the graph of train accuracy, valid accuracy, and loss, and also valid loss. So this is the model we are using. So this is the start of the model, sequential. After that, we are using convolutional 2D. And this is the filtered. Here we mentioned filter 32 for first layer. And second layer we mentioned 64. And the convolutional size is 3. Once convolutional is done, next step is ReLU. It will do the operation element wise. After that, max pooling. It will reduce the height and width of the original images from the size 3x3. Once it is model is defined and layers is defined, third step is flatten. After that, it will flatten, it will convert the 2-dimensional into 1-dimensional. Then activation is used, softmax is used for to classify the classes. And model compile is used for, these are the parameters is used to increase the accuracies. Here we are used optimizer.rms form. Here we are used learning rate 0.004 where it will get the more accuracy. Once model compile is done, fit the model using model.fit. Here include the parameters, train testers, train targets, and validation split is 30%. Epoch means iterations, batch size is 10. And after the model is defined, layers are defined, compile is done, model fit is also done. Then it will display the graph using this command. So history graph, we call this function. Once it is training is done, we will display the accuracy, sensitivity. These are the accuracy parameters it will display once it is trained. Once it is trained, the model will save cnn1.h5 using the command model.save method. Click on run model. You can see the total categories is 9 and the type of erythrocyte diseases. We are equally splitting the data in 164, 164. And these are the iterations. Here I mentioned epochs 100 till 100 iteration. The images are trained. In parallel, you can see the accuracy loss and validation loss. And also accuracy. So still 100 iteration. It's keep on running the code. So you can see the along y-axis accuracy, along x-axis epoch. Here we mentioned epoch 10. For epoch 100, you will get the accuracy and also validation accuracy. So this is along y-axis loss, along x-axis epoch. So here we can see the train loss, validation loss. And then we can see the receiver operating characteristics along y-axis true positive rate, along x-axis false positive rate. Now we can go for the testing code. Click on file, click on testing. So this library is used for to creating the GI purpose, where CVT is used for to display the images, for read the images, and also to write the images. This package is important. And this is for array conversion. And this is the Python image library below we are using. And the model. So here you can see the GUI of erythrocyte classification. Click on load image button. Select any one of the image from the dataset. So here you can see the original image gray conversion. This is the canning. This is the erosion and dilution. It's the fine contour method. Finally, it will display the image shape, size, thickness, diameter, also aspect ratio. Click on predict button. Predicted disease is erythrocytes, and the patient has abdominal. You will get the pop-up message like this. You can check for another input. Click on load image button. Select any one of the diseases image. Select any one of them. Click on open. So you can see the original image, gray, tan, erosion, dilution, and fine contour method. Click on predict button. Disease is macrocytes. The patient has abnormal. Click on open.